everyone! Today we are going to talk about modulus functions. When sketching graphs of modulus functions, normally we need to change the modulus into non-modulus. So generally this is the formula that we can use when changing modulus into non-modulus. So when we want to change the modulus of fx into non-modulus of fx, we will get either positive fx or negative fx. Now we will get positive fx if we know that fx is greater than or equal to 0, or we will get negative fx if we know that fx is less than 0. Now we take this example. Sketch the graph y equals modulus of 2 minus x. Now when we compare this modulus with the formula, so we can see that fx in this example is equal to 2 minus x. So means when we want to change modulus 2 minus x into non-modulus, we will either get a positive 2 minus x, where if 2 minus x is greater than or equal to 0, or we will get negative 2 minus x, where 2 minus x is less than 0. So now we need to simplify the inequality. For 2 minus x greater than or equal to 0, first we shift 2 to the right hand side, becomes negative 2. Now negative x we need to change to positive x. When negative x change to positive x, the important thing is we must turn the arrow, becomes x less than or equal to 2. Then same thing as 2 minus x less than 0. When we change the negative x into positive x, we must turn the arrow, becomes x greater than 2. So now we can rewrite the piecewise function where 2 minus x is when x is less than or equal to 2. Negative 2 minus x is when x greater than 2. After changing the modulus into non-modulus, we found that that is a piecewise function. Now, in order to sketch the graph of modulus function, first we ignore the modulus where we start the graph from y equals 2 minus x. So this is a linear graph where we need 2 points. When x is equal to 0, y is equal to 2. When y 0, x is 2. Now we join these 2 points with a straight line. So this is the graph for y equals 2 minus x. Now based on this graph, now we can get the graph for the modulus 2 minus x. What we need to do is, for the part of the graph which is below the x-axis, need to be reflected up by using x-axis as the line of reflection. So after we reflect the part of the graph below the x-axis up, so finally that is the graph of this modulus function y equals modulus of 2 minus x. So now we need to label. For the part of the graph which is reflected up, that is we need to label as negative 2 minus x. For the part of the graph that is remain the same, we label as 2 minus x. So finally this is the graph for the modulus of 2 minus x. So now we can verify this graph with the piecewise function here. So we look at the graph when x it is less than 2, that is for 2 minus x. For x which is greater than 2, this is for negative 2 minus x. So finally we will get a graph. Now if modulus is only part of the function, for example y equals x minus 2 divided by 2 minus x, where x is not equal to 2. So when we change modulus into non-modulus, only the part of the term which is inside the modulus will change to either positive or negative. The part of the term which is no modulus sign, that is remained unchanged. So for this case, when we change to non-modulus, then we will get x minus 2, which is unchanged, divided by either positive 2 minus x, where 2 minus x is greater than 0, or negative 2 minus x when 2 minus x is less than 0. So here for 2 minus x greater than 0, we don't see a slope here because 2 minus x is the denominator, and we know that denominator is not allowed to be equal to 0, so that's why we don't have a slope here. Then when we try to simplify this one, we find that 2 minus x actually we can change to x minus 2, so that we can cancel off the factor x minus 2. So to do that, for the positive 2 minus x to change to x minus 2, we need to factorize the negative out, becomes negative x minus 2. And when x is less than 2, as for negative 2 minus x to be changed to x minus 2, so we can just expand the negative. So after that, we can see that x minus 2 can be cancelled off. So after cancel off, we will get negative 1 for x less than 2 and positive 1 when x greater than 2. So based on this one, now we can sketch the graph. So first we draw the x-axis and y-axis, and we try to mark the value of x, which is equal to 2, mark the y, negative 1 and 1. Now when x is less than 2 but not included 2, the value of y is negative 1. When x is 2 but not included 2 and greater than 2, the value of y is 1. So finally, this is the graph of the function. In this example, we try to sketch the graph for modulus 2 minus x squared. First, we need to change modulus 2 minus x squared into non-modulus, and we will get positive 2 minus x squared if 2 minus x squared is greater than 0, or we will get negative 2 minus x squared if 2 minus x squared is less than 0. So now we need to simplify this inequality in order to get the range of value of x. For 2 minus x squared greater than 0, first we need to factorize the quadratic into two linear factors. So we will get square root of 2 minus x, square root of 2 plus x. Then we need to sketch the graph of this quadratic, because this quadratic is a negative quadratic, so it is an N shape, and we label the x-intercept. Now because the inequality is greater than 0, so this is the area that we need to take and the value of x in this area is greater than negative square root of 2 and less than positive square root of 2. Now as for 2 minus x squared less than 0, so same thing, we factorize the quadratic, becomes square root of 2 minus x multiply square root of 2 plus x. And same thing, we need to sketch the graph. It is a negative quadratic shape. Label the x-intercept. And since the inequality is less than 0, means this is the area we need. For the left hand side, x is less than negative square root of 2. For the right hand side, x is greater than positive square root of 2. Now we rewrite the piecewise function where for positive 2 minus x squared, the set of value of x is greater than negative square root of 2 and less than positive square root of 2. Now for negative 2 minus x squared, the range of value of x is x less than negative square root of 2 or x is greater than positive square root of 2. Now when come to sketching the graph of this modulus function, we can start from the graph which is without modulus function, that is y equals 2 minus x squared. So 2 minus x squared is a quadratic function, and since negative, so the shape is an N shape. Then we label the x-intercept square root of 2, negative square root of 2, y-intercept is 2. Then from this curve, now we can continue to get the curve of modulus 2 minus x squared. Now when we look at the graph of y equals 2 minus x squared, now the part of the curve which is above the x-axis will remain the same. But for the part of the curve which is below the x-axis need to be reflected by using x-axis as the line of reflection. So after the reflection, so generally this is the curve of the modulus function. Now we need to label the curve. For the part which is reflected, we need to label the curve as negative, which is negative 2 minus x squared. Same as left hand side, since this part is reflected, so we label as negative 2 minus x squared. As for the part which is remain the same, we label as positive 2 minus x squared. So this is the curve for the modulus function 2 minus x squared. Now we try to verify with the piecewise function just now. For the x which is in between negative square root of 2 to positive square root of 2, so we can see that the label is positive 2 minus x squared. As for x less than negative square root of 2, the function is negative 2 minus x squared. And for x greater than square root of 2, the function also that is negative 2 minus x squared. Now in this example, we can see that modulus is only a small part in the piecewise function. So when we change the modulus into non-modulus, the changes is only involve the region which containing the modulus, and also the rest of the part of the piecewise functions remain the same, and the changes only involve those terms which is inside the modulus, and those terms which are outside the modulus remain unchanged. So means 3 minus modulus minus x, when changed to non-modulus, we will get 3 minus positive 3 minus x, when 3 minus x is greater than 0, or we will get 3 minus negative 3 minus x when 3 minus x is less than 0. So now we need to simplify. After simplify, we got x where x is less than or equal to 3, and 6 minus x when x is greater than 3. Now, after the modulus change to non-modulus, we can see that that is a new piecewise function. Now we need to combine this new piecewise function into the original piecewise function. Now we try to use the number line to see. So first, when we look at the piecewise function, when x is less than 1, this region is occupied by x power 2. When x is equal to 1, that is equal to 0. Now we look at the new piecewise function. Before combine, when x is less than 3 or equal to 3, that is for x. When x is greater than 3, that is for 6 minus x. Now when we try to combine the new piecewise into the original piecewise, we found that when x is less than 1, this value of x is not available for x because this region is already occupied by x power 2. So means x, we can only start from 1, then up to 3, and not included 1. Then after that, for 6 minus x, it is available for 3 and greater than 3. So now based on this diagram, now we can rewrite the piecewise function. So when we rewrite the piecewise function, the region which is unchanged, that is x less than 1, it is occupied by x power 2. When x is equal to 1, it is equal to 0. Now for x which is greater than 1, now we need to separate into 2 separate interval value of x. So first one is from 1 up to 3, not included 1 and included 3. Then second one is greater than 3, not included 3. So for 1 up to 3, this is for x, and greater than 3, that is for 6 minus x. So now this is the piecewise function after we change the modulus into non-modulus. Now based on this piecewise function, now we can start sketching the graph. Now we start from the first region, which is x less than 1. When x less than 1, y is equal to x power 2. So this is a quadratic function and positive, so the shape is an U shape. And then we need to mark the region that we are going to take, that is x less than 1. So when x it is equal to 1, y is 1, and x it is not included, so this is the region we are going to take. Then now we go to the second one, that is when x it is equal to 1, y is equal to 0. This is a coordinate point. So we need to mark this coordinate point when x it is 1, y it is equal to 0. Now for the third one. For the third one, for x in between 1 up to 3. In this region, y is equal to x. So this is a linear straight line. So now we draw this straight line. The straight line is a linear straight line going up and goes through the origin. So we try to mark the region that we are going to take, that is x from 1 up to 3. When x is 1, y is 1. When x is 3, y is 3. Where x equals 1 is not included, x equals 3 is included. Then the region, this is the region that we want. Then for the next one, for x greater than 3, y is equal to 6 minus x. Same thing, this is a linear straight line. So in this linear straight line, we need two intercepts. When x is equal to 0, y is 6. When y is equal to 0, x is 6. So we get this straight line. Then we try to mark the part of the graph that we want, that is x greater than 3, not included 3. So this is the region that we want. Now we can combine all these graphs into one single graph. So first we mark the x-axis and y-axis. Now the first graph is when x is less than 1. This graph we take from y equals x squared. That is the quadratic where x is less than 1. So next, when x is equal to 1, y is equal to 0. That is a coordinate point. Then when x is from 1 up to 3, not included 1 but included 3, so this is a straight line. Then after that, for x greater than 3, that is another straight line taken from the fourth graph. So now we label the graph. This is y equals 6 minus x. This is y equals x. Then this is y equals x power 2. So now this is the final graph for this piecewise function. Now we look at this piecewise function. This piecewise function containing a small modulus x. So means we need to change the modulus x into non-modulus. So when changing modulus into non-modulus, the changes will involve those terms which is inside the modulus. The rest of the part of the piecewise are unchanged. So means when we change 2 modulus x minus 1 into non-modulus, we will get either 2 positive x minus 1 when x greater than or equal to 0, or we will get 2 negative x minus 1 when x is less than 0. First we simplify this one. Then we got 2x minus 1 when x greater than equal to 0, and negative 2x minus 1 when x less than 0. So after change the modulus to non-modulus, we will get a small piecewise function. So now we need to combine this small piecewise function into the main piecewise function. So now we try to use the number line to see, and from the main piecewise function we can see that when x is in between -1 up to 1, this region of value of x is occupied by square root of x plus 1 plus 1. Now we go to the new piecewise. When x is greater than 0 and equal to 0, this one is for 2x minus 1. Then for x less than 0, this is for -2x minus 1. So when we try to combine the new piecewise into the original piecewise, we found that for the value of x which is in between 0 up to 1, this is unavailable for 2x minus 1. So 2x minus 1 is only available when x is equal to 1 and greater than 1, included 1. Same thing for x in between -1 up to 0. This region of x is not available for 2x minus 1. Whereas -2x minus 1 can only start from -1 and less than -1 and included -1. So based on this diagram, now we can rewrite the piecewise function. Now when writing the piecewise function, normally we start from the smallest value. So based on this diagram, we start from x less than or equal to -1. Then we go to -1 up to 1. Then finally we go to x greater than 1. Then for x less than -1, that is for -2x minus 1. For x in between -1 up to 1, that is for square root x plus 1 plus 1. And for x greater than 1, that is for 2x minus 1. So this is the piecewise function after we change the modulus into non-modulus. Now, based on this piecewise function, now we can start sketching the graph. So the first one is when x less than or equal to -1, y is -2x minus 1. This is a linear graph. So when sketching linear graph, we need 2 points. When y equals 0, x is -2. When x 0, y is -1. Now we need to mark the part of the graph that we need to take, which is x is less than -1 and included -1. So this is the region that we are going to take. So now for the second graph, where x is from -1 up to +1. This is for y equals square root of x plus 1 plus 1. So this is the square root function. To sketch this graph, we can use the transformation method that we have learned, where the curve we shift to the left for 1 unit and shift upward for 1 unit. So this is the curve, and then we try to mark the region that we are going to take. So that is from x equals -1 up to x equals 1. So when x equals 1, where x is not included and negative 1 is not included. So then this is the region that we are going to take. Then for the last one, when x is greater than or equal to 1 and y is 2x minus 1. This is also a linear straight line. So we need 2 points when x is equal to 0, y is negative 1, when y 0, x is 1 over 2. So the region that we need to take is x is greater than 1 included x equals 1. So this is the region that we are going to take. Now we can combine all these graphs into one single graph. So to do that, first we mark the x-axis and y-axis. For the first graph, when x is negative 1, y is 1, the first graph is a linear where x is less than negative 1. So we take from the first graph, then followed by the second graph where x is in between negative 1 up to positive 1, that we take from the second graph, that is square root of x plus 1 plus 1. Then followed by the third graph when x is greater than or equal to 1. Then we take from the third graph. So finally we label the graph. This is y equals 2x minus 1. This is y equals square root of x plus 1 plus 1. And this is y equals negative 2x minus 1. So finally this is the graph of the function. Thanks for watching.